Good afternoon. My name is Sriram. I welcome you on behalf of Glasses Green for today's webinar. The topic for today is futuristic facade. Uh, the, the agenda of my presentation, which I would be covering, would cover about coating technology, which talks about the solar and the thermal control facades and selective and super selective energy efficient facades. The second topic that I would be covering would talk about the active systems which are dynamic in terms of performance. And the last topic that I would be covering would be on ceramic frit, how to integrate energy efficiency, visual comfort along with aesthetics. With this as an agenda, let me start with coating technology. In the past, the coating technology has been predominantly the online coating technology, which is a pyrolytic coating. The disadvantage of online coating technology would be it's in terms of selectivity, which means that the energy efficiency parameter does not meet the green building energy efficiency standards. What we have in present is the offline coating technology, which is driven by energy and aesthetic selection. The selectivity of these glasses are very high, and it's in the range between 1 to 2 and meets the benchmark requirements of green building codes such as energy conservation building code or green building rating systems such as LEED and Griha's rating system. What I would like to present is the super selective coating, the offline coating technology, which has selectivity greater than 2, and it outstrips in terms of the building regulation codes. Selectivity is an important aspect in terms of selection of glass. What is selectivity? It is a ratio of light transmission to the solar heat gain. And generally, if you have a high selectivity, it indicates that the performance of the glass is very high. So selectivity is a ratio of visual light transmission divided by solar factor, or otherwise called as solar heat gain coefficient. So it's a number, and if you see how glass has been evolved over due to its kind of coating and also the technology, here the first comparison that you see, when I compare an online coated glass with an offline coated glass which gives the same kind of solar performance, here you can observe that for the same 46% of heat transmission, I have a greater light transmission, which means that I reduce the energy that is required for heat gain and also minimize the heat gain, minimize the energy that is required for light, artificial lights during daytime operation. As I move on, when I use high-end energy efficient glasses like single silvered low E glasses, for the same light transmission, which is about 46 or 47% light transmission, I have 10% absolute value reduction in terms of solar factor. And when I compare the double and a triple silvered, when the light transmission increases to about 50%, whereas the SHGC of the glass is reduced from 27, and in terms of triple silver product, it is 22. So what we observe here is, by going for an offline coating technology, which is slowly replacing or preferred choice for the building facade, the light transmission of the glass facade is met without compromising the energy aspect, and the heat gain that happens through the facade keeps decreasing. And what we foresee in terms of future, a selectivity of 2.5, where you have a light transmission about 50% and the solar heat gain coefficient of 0.2 or maybe 0.18. But when we move into this offline coating technology, this is quite common in the present scenario also. There is always a comparison saying online versus an offline coating technology, whether the coatings are durable, whether the offline coating technologies are durable in terms of robustness of the product and also life of the product. To answer this question or to clear off this dilemma, if you see the standard codes, the requirements of coated glass for building facade, for example, EN 1096, which talks about glass for building coated glass, they don't define coatings based on how it is manufactured, whether it's an online or an offline application. They define types of coating based on application. So they are classified into three types of coatings. One is class A, the second is called as the class B, and the third is class C. So class A kind of coating is the type of coating, either online or an offline coating technology, in which the coating can be faced outside. Outside, I mean in terms of facing the environment, or it can also face the inner, which is the inside of the building. Whereas class B represents coated glass, which is used in monolithic or it can be used in double glazed unit, and the coated surface has to be facing inside. Here you have both online coated products and also offline coated products, which come under the classification of A. There are specific products, and you also have specific products which come under the criteria of B. The third kind of coating classification of coated glass is the type of coating which has to be used in IGU or multi-glazed unit. These are typically called as low E glazings. Low E means low emissivity, and the low emissivity, the most commonly used material for bringing out the low E property is silver. And silver needs to be protected from the external environment, because when silver is exposed to humidity which is present in the atmosphere, it reacts with the water vapor and forms silver oxide. So in order to increase the life of the coating and also protect it from the internal and external environment, it is always recommended that class C kind of coating is used in IGU or in a double glaze system. So what we here see is the classification of coatings in terms of durability is not defined by how it is manufactured, whether it is an online or an offline coating, but what is the type of application the glass is being intended to use for. Now let us see what is the ideal suited glass for a tropical country. This graph that you see here, the x-axis represents the solar factor, which varies between 0 to 1, and the light transmission, which is measured in terms of percentage or ratio, is in the y-axis is between 0 to 1. Now you have three separate classification. What you see in the lower end, which is highlighted in light gray, is the area which you don't want to be in as a glass manufacturer or a customer, because the light transmission is very low and the solar factor is very high. So it's not an ideal place for any of the glass to be in. What you see here in the dark gray area is the place where you would ideally like to be in, which talks about very low solar factor and a very high light transmission. But there is a typical constraint in terms of the amount of light transmission and also the solar factor. So ideally, if you see the middle section, which is represented by light blue color or faded white color, is the place where most of the glazing products are present. And here you see there are two classifications, one on the top, which is an optimal requirement for a cold climatic places like Europe, where you have predominantly heating requirements and temperatures are always below the ambient temperatures in terms of set point temperatures. So here you prefer a glass which is having a very high solar factor, because any heat gain will help you reduce the artificial heating requirements for the indoor application. Talking more in specific to hot climatic countries like India, you would ideally like to be in the oval region, which is marked, where you have a optimal balance between the light transmission and a very low solar factor. So comparing to this requirement, how does various products stand? Here you can see the first in terms of clear glass, which does not have any kind of solar protection and it has an excessive light transmission, falls under the top category. The area highlighted in green is a body tinted glass, which is typically your green, blue or bronze or dark gray tinted glasses, which reduce the light transmission and also heat transmission in comparison to the clear glass. Then you have a wide range of pyrolytic coatings, the circle which is indicated, which helps you to optimize further in terms of light transmission and also heat transmission. But here you see that the offline coating technology is very close to the most favorable area in terms of dark. So the products which are inclined more towards the dark gray area is considered to be more useful and more relevant for tropical climatic condition. So these are basic form of glasses where the application started from clear glass, then people started using for tinted glass in order to have optimization in terms of light transmission and also in terms of energy efficiency. Then came the technology in terms of pyrolytic coatings, which was better than the coated glass in terms of solar protection and also optimum light transmission. Then evolved the technology of offline coating, which increased the benchmark requirements in terms of the optimization of light transmission and also in terms of reducing the heat gain. Now you have technologies which are very close to the actual requirements, which is high performance glasses. These are typically called as low-E glasses, and these low-E glasses provide both solar and thermal insulation. You have coatings which is of nanometric thickness, and you have products which are single silvered, double silvered and triple silvered, and by increasing the number of layers of silver, what it benefits from an end perspective or a customer point of view is that the architect can design a building allowing a good amount of natural daylight inside the interiors and also reduce the heat gain that takes place through the facade. So you minimize the lighting cost during daytime operation, and in the same time light also is a component of heat, so you don't allow the heat factor, so the energy that is consumed for cooling requirements also comes down. So here you see that what the coating technologies like your double silvered and a triple silvered product provides an excellent light transmission, which completely eliminates the need for natural artificial lights during daytime operation and significantly reducing the cooling cost which is required for the thermal comfort, and we see that this is most preferred choice in terms of green building specifications. What we have we now move on